Okay, let's begin. We are at the next chapter already. The first thing we are going to find is the nature of the stationary point, which means are we having a maximum point, minimum point, or a point of inflection. Okay, just to quickly recap. When the curve is this shape, you have a maximum point here. When it's this shape, I have a minimum point. When I have this shape, I have a point of inflection. If I have this shape, I have a point of inflection. Now what happens if I have this shape? What type of stationary points do I get? I'll get a maximum and a minimum point. Okay, let's go through this. Now how do we find the coordinates of the stationary points? At all the stationary points, what's so special about the gradient? Okay, the gradient is 0. Okay, you look at this inflection line. Okay, for example, I get positive, right? 5, 4, 3, 2, 1. I must reach 0 before I can become 1, 2, 3, 4, 5. So I must reach a 0. So all the dy dx at the stationary point is 0. So to find the coordinates of the stationary points, I need to always let dy dx be equals to 0. Okay? Stationary points. So let's differentiate this. I have 3x squared minus 12x plus 9. I must let this to be equals to 0. Are you going to factorize this straight away? What must you do first?
Simplify.
Simplify. I already differentiate finish already, so simplify. So I get x squared minus 4x plus 3 equals to 0. So now I can easily factorize, even without using a calculator, I can easily factorize, and x is 1, x is 3, y is 6. When x is 3, I sub it back here, right? Y is 2. So what are the stationary points? 1, 6, and 3, 2. I will draw the curve for you, just for illustration purpose. So it's a cubic curve. So the curve will look like this. So later I will have 2 turning points here. No need. I draw so that when I teach this topic, you can understand and see the relevancy. So you realize I got 1 maximum point, and I will have 1 minimum point later. Okay, I teach you how to do it without the diagram. So please follow this method. Hey, draw this. It's a bit like tic-tac-toe, but basically you have 1, 2, 3, 4, 4 by 3. It's a 4 by 3 box. It's very important. Please follow this. Now the first part here is x. I'm going to use red color. Then here will be dy dx, and then this will be the slope. Can you please follow this sequence? Please follow this sequence. Very, very important. Okay, now the turning points, I know that it's 1, 6, right? So I put the 1 here in the middle. I will check the point that is a bit to the left. Okay, let's say it's a turning point. I don't know maximum or minimum. So this is the point here. Let's say this is the point. X is 1. I don't know which one it is. I test a point that is near here. So we call this point 1 minus. I have a number that's slightly bigger, slightly only. 1.1. Question. Why do I test a number that's slightly smaller and slightly bigger? Not like, why don't I test like 0, 1, 2? Why don't I test a number so far away? Do you know why? If I test a number that's very far away, okay, that's why I draw a picture. I want to test a number here. I want to test a number here, right? If I test a number too far away, it may go to the next turning point already. So we always test points that are immediately next to it. But don't have to be so kiasu and test until like 1.00000001. No need to be so kiasu. 1.1 is enough. Okay? So what do I mean? I'm going to test this point and this point. I don't know which graph lah. I really don't know. So I'm going to test. Now, when I put a number 0.09, okay, for this instance, I'll write down for the sake of learning only. Now, during exam, you just need to write 1 minus 1 and 1 plus. Yeah, dy dx, sorry, dy dx. I'm going to put into dy dx. 0.09 square, 0.09, I put here. What is the slope if x is 0.09? What is the slope, plus or minus? You have to press calculator. 3 times 0.09 square minus 12 times 0.09 plus 9. Just press calculator. The number is a positive or negative number. You get a positive number. You don't believe me, you press out, you get a positive number. Okay, next. What happens if I put 1? Hey, this one, listen up. This one. If I put 1 here and if I put 1 here, what will happen? I should get 0 ma. If you don't believe me, you just press up. Okay, what's the next one? I will put 1.1 here, I'll put 1.1 here. You press calculator, you get a negative number. So, usually students stop here in the table and they can straight away tell what point is this? Yeah, maximum point. But why do I have this table? Because positive slope you draw like this, zero slope you draw like this, negative slope you draw like this. Now this is very obvious. What type of point is this? Nah, this is maximum. That's why I insist that you do this table. So I have this point here, 1, 6, right like that, present like that. And right in front, maximum or minimum? I have a maximum point. Okay, next one. Again, I have my x, my dy dx, and my slope. Now, if you can see straight away whether it's maximum, minimum, I don't need the last row lah. But I really hope that when you're beginning, you do this. So I submit another x value. Now the x value is 3. Then I put in 3.1. And I put in 2.9. All right? So when I put in 2.9, I put here 2.9, 2.9, and I realize I press calculator, the answer is negative. When I put in 3, obviously the answer is 0. When I put in 3.1, 3.1, are you able to see whether is it a maximum or minimum? Cannot, right? Then you draw the slope. Negative slope, 0 slope, positive slope. What type of point is this? How do you present your answer? You present answer as minimum point, bracket 3, 2, and we are done. So this is the nature of the stationary point, 3, 2. This is the nature of the stationary point, 1, 6. I drew the diagram just for illustration purpose. Exam, of course, nobody is going to draw this. So this is 1, 6. And then this one is 3, 2. Can you see that this is a maximum point? This is a minimum point? That's how you get it. And the curve, for this curve, it will look like that. Okay, this is the curve. I drew it just for illustration purpose again. Exam, there's no curve. Okay, so let's try. First thing is find dy dx equals to 0, right? That's the first job. So dy dx equals to 0, very simple. What is the answer? Please tell me. Yes. 3x squared plus nothing, because when you differentiate a constant, it becomes nothing, 0. So this one equals to 0. I differentiate. I let it be equal 0 because all stationary points, the gradient must be 0. So when 3x squared equals to 0, x equals to 0, I substitute back here, y equals to 1. So your turning point will be 0, 1. Good news, there's only one turning point. So I am going to do the table again, the 4 by 3, or 3 by 4, sorry, 3 by 4 table. 3 rows, 4 columns, 3 by 4. Okay, so this is your x, dy dx, and then your slope. Now your x value is 0. Something bigger will be 0.1. What is a number that's smaller than 0? Negative 0.1. Please don't mess this up. Is it very difficult for you to write like that? Then please write like this instead. Look here. I put negative 0.1 and I put positive 0.1. Is it nicer like that? You can do that also. Like I say, this one got no marks. So if I sub in 0.1 into my dy dx, which is here, dy dx is this guy here. I put negative 0.1. I get positive because it's a perfect square. If I put 0, it will be 0 obviously. If I put 0.1, positive 0.1, it's still positive. Can you see what point is this? If you cannot see, yeah, draw the slope. If you can see, you can skip this part. I cannot see, I draw the slope. This is from left to right, it look like that. So this is called a point of inflection. Okay, and that's the end of the video. Okay, Jacob?